Assalamualaikum. My name is SHALIN binti SELLEHUDDIN. I am from Group 5, EH2434B. My other group members are Mohammad Azrien and also Mohammad AIMAN. Today, we're going to present about free and forced vortex. So for the brief outcome, we have divided into 3 sections, where the first one is introduction and theoretical will be explained by me, SHALIN, and second one, result and discussion, will be presented by Mohammad Azrien. Lastly, the analysis of conclusion and recommendation by Mohammad AIMAN. As for introduction, I'll first explain the meaning of vortex. According to Merriam-Webster Dictionary 2021, vortex is a mass of fluid with a whirling or circular motion that tends to form a cavity or vacuum in the center of the circle. Vortices can occur naturally or demonstrated in lab. Therefore, there are 2 types of vortices: free vortex flow and forced vortex flow. The free vortex flow is formed without any external force applied. It naturally occurs when the fluid mass rotates due to the conservation of angular momentum, where water flows out the vessel through the central hole in the base. Therefore, this experiment conducted to understand the relation between surface profile of free vortex with the velocity. Next is forced vortex flow. It occurs with the presence of external energy. The vortex forms as the fluid rotates about the vertical axis in the constant speed, which can be created by rotating a vessel containing fluid or paddling in fluid. For instance, rotating plate with additional paddle is used in this experiment to create the forced vortex in order to study the surface profile of forced vortex and its relation with the angular velocity. In this experiment, the physical phenomena associated with free and forced vortex flow can be identified. Whirlpool in the river and tornadoes are examples of natural free vortices. Meanwhile, the example of forced vortex can be seen in industry, such as turbine design. Moving on to the theoretical explain about free vortex. The water moves spirally towards the center with a streamline motion, which by neglecting losses caused by viscosity, and energy unit per mass will be kept constant. As shown in the surface profile of free vortex, as it goes down, the radius decreasing, which leads to 0 radius at the center of rotation. And the only travel velocity component is tangential, where the tangential speed varies with radius in order same circulation is maintained. The velocity varies inversely with the distance from the axis of rotation, which simplified into equation 1, V equal to K over R. The fluid near to the center of the vortex will circulate faster. At the same time, the inner stream have shorter distance to travel to complete the ring. The equation governing the surface profile is derived from Bernoulli theorem. P squared over 2G plus Z equal to C. Substituting first equation into the second equation, simplify as K squared over 2G R squared plus Z equal to C. Theoretical explain about forced vortex. The forced vortex flow when fluid is rotated about the vertical axis at constant speed and every particle has the same angular speed. The fluid is rotating by using external energy. When the fluid starts to rotate, the fluid is on forced vortex motion. There is depression or pressure at the center, then it rises at the end of the wall of the tank and forms a concave surface. When water is forced to rotate at constant speed, the velocity will also be constant. Therefore, V is equal to angular times R. The velocity head formula is hc equal to V squared over 2G. Substituting 2 equations equal to hc equal to R squared angular squared over 2G. If the horizontal plane passes through the lowest point of the vortex is selected as that term, the total energy will become H equal to HO plus HC. At the condition of R equal to 0, H equal to 0, therefore HO will equal to 0, and simplify into H equal to R squared angular squared over 2G. The equipment mainly used in this experiment is Vortex free and forced vortex model FM24, which is designed to produce and measure the characteristic of free and forced vortices. For the setup, there are nozzles with 9 mm diameter and 12.5 mm diameter. The orifice with 4 different diameters, 8 mm, 12 mm, 16 mm, and also 24 mm. Profile measuring gauge, ladder, 3-way inlet valve, outlet valve, and also pitot tube. Now, I'll explain about the procedure of this experiment. First, start with the general startup procedure. The study bench was placed on the hydraulic bench, the inlet and outlet hose was set up, the stand of equipment was adjusted to reach the horizontal position. Then, the experiment can be carried out. The first experiment was free vortex flow. Once the general startup procedure performed, an orifice with diameter of 24 mm was selected and placed in the cylindrical tank. The output valve was closed and the 3 inlet valve was adjusted to let the water flow into the tank from 2 pipes with diameter of 12.5 mm. The pump was switched on and the control valve on the hydraulic bench was opened slowly until tank limit. The water level was maintained by adjusting the control valve. When the water level was stable, the vortex profile had collected by measuring the vortex diameter for several planes using the profile measuring gauge. The profile measuring gauge was pushed down into the both sharp point touch the water surface. The height was measured from the top profile measuring gauge to the bridge. The pitot tube was used to measure the velocity by sinking into water at the depth of 55 mm from the water surface. Step 3 and 8 were repeated for another 3 orifices with diameter of 12 mm, 16 mm, and also 8 mm. The second experiment is forced vortex flow. Once the general startup has been performed, a closed pump with 2 paddles has placed in the base of the cylinder tank. The output valve was closed and the 3 inlet way valve was adjusted to let the water flow into the tank from 2 pipes, which is 9 mm and also 12.5 mm. The water was ensured to flow out from the tank with the siphon effect by raising the hose to the above water level in the tank. The outlet hose was ensured filling the water before letting the water to flow into the sump tank in the hydraulic bench. The angular speed of the paddle was measured by counting of number of circles in 60 seconds. The surface probe was pushed down into the sharp point, touched the water surface. The measure height, HO, from the top of measuring gauge to bridge was recorded. Step 4 until 8 were repeated with different volumetric rate. Lastly, once all the experiments have been conducted and the data have been recorded, general shutdown procedure need to be applied. The valve was closed and the pump was switched off. The orifice, paddle, and other accessories were removed from the cylindrical vessel. And lastly, the water power is shut down.
Assalamualaikum warahmatullahi wabarakatuh. My name Mohammad Azrien bin MAZLAN. Today I'm going to present to you about experimental data, result and calculation for free Vortex. Okay, in free Vortex experiment, we have 3 different diameter of orifice, which is 12 mm, 16 and 24. Okay, in this data, the importance variable that we need is actual velocity, radius, 1 over radius power of 2, and value of k, and theoretical velocity. For discussion free Vortex, we plot a graph which is power heat against 1 over radius power of 2. We can get gradients. Okay, for gradient, we can calculate theoretical velocity. Okay, as we observe, the gradient increase when the diameter of orifice increase. Besides that, discussion for free Vortex, we also want to know the velocity in actual and the theoreticals. Okay, as a result, from the observations, we can say that velocity, actual velocity, have high velocity from the theoretical velocity. As an example, the same result we get even we change the diameter of the orifice, the result always shows that the actual velocity have higher than the theoretical velocity. Next, the experimental data for force vortex, first we calculate the angular velocity, which is the unit is radians over seconds, and we calculate the value of h for each distance from the center. Okay, the result you can see as the table, as in a table. Lastly, discussion for force vortex, we plot a graph to see how the trend lines of the force vortex. Okay, we plot a graph height from the top surface prop bridge against the distance from the center. Okay, for the first experiment, we can say that the value of h increase and suddenly decreasing when the distance from the center reach 70 millimeter. Okay, for the second experiment, we can say that the value of h increasing as the distance from the center increasing. Okay, the result for the second and the third experiment are same but different in value. We can say that what we can conclude is the value of h are affected by the distance from the center.
Assalamualaikum, my name is Mohammad AIMAN bin ZULKIFLI, and today I will present about the conclusion and also the recommendation for this experiment. Okay, next I will talk about the conclusion. So the conclusion that I can make from this experiment, the first one, for the free vortex flow, the velocity decrease as the bigger diameter of orifice increase. It also shows that a bigger diameter of orifice will create a greater vortex and increase the surface profile of the vortex flow. And the next conclusion is for force vortex flow, when angular velocity increase, the surface profile also increase. The slope of the curve increase as angular velocity increase. This is because the stream function formed in force vortex is parabolic in nature. Lastly, for the recommendation of this experiment, the first one is to ensure the water level in the vessel is constant. This is to make sure that we can obtain more accurate height from the vortex formed in the bridge. And second one is to fully prepare with correct measurement equipment so it can ease the process of recording the data. It will be great if we use equipment that have a high accuracy rate so that error can be avoided and we does not need to repeat the experiment again. And the last one is to ensure that the ice level is perpendicular to the pitot tube when we record the data. So it is to avoid the parallax error. That's all from us. Thank you.